Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem using the method of undetermined coefficients. So let's get going. Problem: solve d square minus 3d plus 2 into y equal to 6 e power 3x. We can write the given differential equation as, see, the given differential equation is in operator form d, right? And also we can write this as d square y minus 3 dy plus 2y equal to 6 e power 3x, or we can write it as d square y by dx square minus 3 into dy by dx plus 2y equal to 6 e power 3x, or y double dash minus 3y dash plus 2y equal to 6 e power 3x. So we'll use the first form and also the last one. Okay, fine. Now coming to the problem. Given d square minus 3d plus 2 into y equal to 6 e power 3x, which is an operator form, f of d into y equal to q of x, where f of d equal to d square minus 3d plus 2 and q of x equal to 6 e power 3x, right? And also we can write the given equation as y double dash minus 3y dash plus 2y equal to 6 e power 3x. Consider the given equation as equation number 1. Okay, now we need to find the general solution to the given equation, which is given by y equal to yc plus yp, where yc is a complementary function, yp is a particular integral. We'll find yc using the auxiliary equation, right? The auxiliary equation is f of m equal to 0, where f of m equal to, see, we have f of d square minus 3d plus 2, right? Let's replace the differential operator d by m, so that we'll get f of m equal to m square minus 3m plus 2, right? Then the equation, auxiliary equation, becomes m square minus 3m plus 2 equal to 0. Now we need to find roots to this equation. Let's split minus 3m as minus 2m minus m. Now take m common from the first two terms and take minus common from the next two terms. M minus 2 exists in both the terms, so let's take it common. We'll get m minus 2 into m minus 1 equal to 0, right? Now equate each factor to 0. When m minus 2 equal to 0, m equal to 2, and when m minus 1 equal to 0, m equal to 1, right? The roots are real and distinct. M equal to 2, 1 are the real and distinct roots to the auxiliary equation. Fine. Now we'll write the complementary function with the help of these roots. We know that when we have two roots which are real and distinct, say m1 and m2 are real and distinct roots, then yc looks like one constant e power one root into x plus another constant into e power another root into x, right? So let's now write the complementary function to our problem using this formula. Complementary function yc equal to c1 e power 1 root, say 2 into x, plus c2 e power another root, say 1 into x, which gives us c1 e power 2x plus c2 e power x, right? Therefore yc equal to c1 e power 2x plus c2 e power x, right? We have yc equal to c1 e power 2x plus c2 e power x, and q of x equal to 6 e power 3x. Now observe the terms of yc and q of x. here you're having, just observe the terms, the functions of x in yc and q of x. Okay, you have e power 2x, e power x and e power 3x, right? We don't have any common terms. Q of x has no common term with yc. Here we are having e power 3x, but in yc you are having e power 2x and e power x, right? So therefore we can say that q of x has no common term with yc, right? Therefore yp must contain the linear combination of q of x and all its linearly independent derivatives. Okay, first we'll see the direct formula of yp, later we'll go for the trial method. Okay, again use or apply the direct formula. Suppose if you forgot the direct formula, you can just make a trial to find the formula of yp. Okay, fine. Now coming to the formula, when q of x equal to e power 3x, say some e power ax, then yp will be constant or quotient, whatever, into e power ax. This is a direct formula. Okay, we can use this formula or we can just make a trial. Suppose we have q of x, so yp will be, your formula is yp equal to a e power ax, right? Suppose you forget the formula. Now we have only q of x, which is, I'm considering just a function of x e power 3x. Okay, we'll just neglect the constant c1, c2 and 6 here because we have functions of x beside it, right? So I'll take q of x, which is e power 3x. I'll find its derivatives. So derivative of e power 3x is 3 e power 3x and derivative of this is 9 e power 3x. Likewise, derivative of is 9 e power 3x is 9 3 is a 27 e power 3x, right? Now I'll write q of x and all its linearly independent derivatives in a set form. Okay, and remember that we should not write the repeated terms in this set. Okay, so q of x has e power 3x, and now look at the derivatives of it. We have e power 3x, e power 3x, e power 3x. The only function of x in q of x and q dash of x, q double dash of x, q triple dash of x and all its derivatives is e power 3x. Okay, forget about the constant. So you have only e power 3x. Q of x is e power 3x and all its derivatives has e power 3x. So we'll write only one, right? Now with the help of this we'll write the formula for yp. Yp will be a into e power 3x. The quotient of x is 3 here. So our formula for yp will be a e power 3x, right? We'll just compare e power ax with e power 3x. Then for a equal to 3, we'll just replace this by 3. This is the formula. Okay, see, when q of x is e power ax, then yp will be a e power ax, right? So when q of x is e power 3x, then yp will be a into e power 3x. Okay, this is the trial method. Just go for it. Okay, fine. Now we got a yp. We have chosen the yp such that it satisfies the given equation, right? So we can write the given equation in terms of yp. You'll get yp double dash minus 3yp dash plus 2yp equal to 6 e power 3x. Since we have chosen yp such that it satisfies the equation 1, so we can write equation 1 in terms of yp. We'll get yp double dash minus 3yp dash plus 2yp equal to 6 e power 3x. So here we are having yp dash and yp double dash, right? We have yp which is a e power 3x. So with the help of this, we'll find yp dash and yp double dash. So fine, we have yp equal to a e power 3x. Let's find yp dash, which is a into derivative of e power 3x is 3 e power 3x, which gives us 3a e power 3x. Now find yp double dash, which is equals to 3a into derivative of e power 3x is 3 e power 3x, which is 9a e power 3x, right? We got yp dash and yp double dash. Now 1 becomes, or we can write 1 in terms of yp, since we have chosen yp such that it satisfies the given equation, right? Now substitute yp double dash, yp dash and yp here. Yp dash is 3a e power 3x plus 2 times yp a e power 3x equal to 6 e power 3x, right? Which gives us 9a e power 3x minus 3 is a 9a e power 3x plus 2a e power 3x equal to 6 e power 3x, right? So here you can cancel 9a e power 3x minus 9a e power 3x, and you'll get 2a e power 3x equal to 6 e power 3x, where e power 3x gets cancelled. 2 1s are 2 3s are a equal to 3. We got the value of a. Now substitute the value in yp. We have yp equal to a e power 3x, which is equals to 3 e power 3x. Therefore yp equal to 3 e power 3x. You can just verify yp using 1 by f of d into q of x. Okay, we can verify using this formula. Yp equal to 1 by f of d into q of x. It's yp, okay? Fine. Now we got yc and yp. Let's now find the general solution to the problem. Therefore, see, this is a verification part for yp. See, you got the same thing, e power 3 e power 3x. Therefore, the general solution is given by y equal to yc plus yp. Then y equal to yc c1 e power 2x plus c2 e power x plus yp 3 e power 3x. Therefore, y equal to c1 e power 2x plus c2 e power x plus 3 e power 3x is the required solution to our problem. See, if you take m equal to 1 2 instead of m equal to 2 1, then the solution will be y equal to c1 e power 1 x, that is x, plus c2 e power 2x plus yp 3 e power 3x. Okay, I took 2 as the first root and 1 as the second root. Fine. Well, we have seen a problem using the method of undetermined coefficients in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.